A few days ago, I made a tutorial called the 3D tunnel, which gave the impression that you were traveling through a twisting, turning tunnel. Today I'm going to do a similar 3D tutorial, but a much shorter one, which gives the impression that you're in a spaceship flying through the stars in outer space. So let's get started by creating a new project. As usual, we'll start by adding a green flag block. So when the green flag is pressed, what are we going to do? The first thing we'll do is hide Scratch Cat. He has no place in space, he doesn't have a spacesuit on, so let's hide him. And now we're going to set some variables up. First of all, how many stars are we going to have in our world? So we'll put that in a variable called numStars. There's only one sprite in this project, so everything is for this sprite only. And we'll set numStars. We're going to have 1,000 stars. Now, if you find your computer slowing down because it's trying to draw too many stars, you can just lower the number in this variable. I'm going to delete the my variable, default variable, because I never use that. So we've got 1,000 stars, and now how big is our world going to be? I'm going to set a variable called world size. And I'm going to set that to 1,000 as well. So what this is going to mean is that my world goes 1,000 meters to the left, 1,000 meters to the right, and 1,000 meters away in front of me. I don't really care about what's behind me because we're not going to see anything behind us. So that's the world size setup. And we're going to initialize all the stars in our world. So I'm going to do that in a custom block without screen refresh to make it nice and fast. I could just add the code under here in the green flag section, but it's much easier to read the code. If I have a custom block, I know exactly what the line is doing. It's going to initialize all of the stars. So let's do that. How are we going to store the stars? We need to store their positions. So we're going to store their x coordinates in a list, and we're going to store their y coordinates in a list, and we're going to store their z coordinates in a list. Now, I'm sure you're familiar with x and y coordinates as you use them all the time in Scratch. A z coordinate puts it all into 3 dimensions and tells you how far away in the distance a coordinate is. So what we need to do when we initialize them, make sure first of all that the lists are all empty. So we'll delete all of star x, all of star y, and all of star z. And now we're going to loop through them, just setting them to their original positions, their initial positions. So I need another variable called index, obviously for this sprite only. I'll set index to 1, and then I'm going to loop through for each and every star. So that's a control, and it's a repeat block, and the number of times I'm going to repeat is numStars. Again, I could have just used a number here. I could have said a repeat 1,000, but it makes the code so much easier to update and so much easier to read if I've used a variable instead. I know what numStars means. I might forget what 1,000 means. So I'm going to loop through that, and I'm just going to set all the positions to 0 to start with. So star x, star y, and star z, all 0. Change index by 1. So that loops through. That's going to create 1,000 stars all at 0, 0, 0. But I don't really want them to start at 0. So I'm going to add another custom block. And I'm going to call this place new star with index, colon, and add an input called index. And then another label called at depth, which will tell me how far away I'm making this star. Add an input, z. I'll run without screen refresh. And let's pull this down here. So after I've set all the coordinates to 0, I'm then going to actually position it where I want it to be. So the index of this one is index. And the depth, how far away do I want it to be? Well, I'm setting them up at random places, so the depth can be anywhere between 1. If I have it at 0, that's exactly in my face, that's no good. So slightly away, it can be anything from 1 meter away to world size. Okay, now let's have a look at this custom block. We want to set up the position in the world for this variable, so I'm going to use 3 new variables: world x, which is a world x coordinate, world y, which is the y coordinate, and I bet you can probably guess world z, which is a z coordinate. So we're going to set world x, we're going to set world y, and we're going to set world z. Well, what are we going to set them to? World x, it can be anything up to 1,000 meters to the left and anything up to 1,000 meters to the right, based on world size. So we'll use the random blocking operators, and it'll go from 0 minus world size, which in this case is a minus 1,000, up to world size, which is plus 1,000. And I'm going to duplicate that block and put it in world y. So the y coordinate will be the same, and the z coordinate I've actually passed into here. So world z is whatever I've passed in there, which happens to be another random distance. And now I'm going to actually update the list with these values. So I will replace item index of star x with world x. And I'll do similar with y and with z. So I'll just duplicate that, change it to star y, change it to star z. If I right click on the variable, I can change the name, so change the variable I'm using to world y, and similar for this to world z. So now I'm setting up the position in 3D space of all of the stars. So if I run this code, it won't do anything obvious that you can see, but if I have the lists on screen, a little bit bigger. So I can actually see them and run the code, and you can see they're all being populated to a length of 1,000 with random values. So let's hide those again. So what should I do next? Well, how about adding something so that I can actually see the stars? We're going to use a pen to draw the stars, so let's add the pen extension. And let's add another function called render stars. Well, draw stars, we'll call it draw stars. And this will draw all the stars to the screen. We'll run without screen refresh to make sure it happens very quickly. You can experiment with this, you can turn that option off and run with screen refresh later if you want. See the difference it makes? So I'm going to draw my stars in bright green. No, I'm going to draw them white. You could draw them bright green if you want. Draw them any colour at all. And I'm going to set the pen size to 2. I think. Yeah, why not? Set pen size to 2. So quite small but visible. And we're going to have to loop through all of the stars. So we'll use the index variable again. We'll start with index of 1. And again, we're going to repeat. How many times are we going to repeat? We're going to repeat num stars times, because we're doing this for each and every star. And for each and every star, we're going to just draw a dot on the screen. But at the moment I've got 3D coordinates. I want them to turn into screen coordinates. So instead of an X, Y, and a Z, I want to actually see them on the screen. And the way perspective works is things further away will appear close together and smaller. So I'm going to add a function that converts the 3D coordinates into 2D screen coordinates. And I'm going to call that function perspective transform. And this will transform the coordinates from 3 dimensions into screen coordinates. So I'm going to I had 3 inputs for this, X, Y, and Z. X, Y, and Z. I haven't added any labels for this because this is an easy one to remember. You can add labels if you wish, but it's usually a good idea. I'm just saving a bit of time there. So perspective transform. And for a perspective transform to work, we need one more variable, which tells us how far away we're focusing. We need to project things onto an imaginary screen in front of us. So I'm going to create a variable called distance to viewing plane. And changing this value makes a big difference on the appearance of how the perspective works. I'm going to set this value to 100. Again, you can play around with this value if you want and see what difference it makes when the project's finished. So we'll set distance to viewing plane to 100. And the perspective transform, I'm not going to use world X, Y, and Z. I'm going to use screen X and screen Y because it's actually going to make coordinates I can use on my screen. So let's set screen X to something multiplied by X. And let's set screen Y to something multiplied by Y. As I said, the further away, the closer together things will appear. And what we're going to put in here is a divide statement. And we're going to divide distance of viewing plane by the distance of the coordinate. And I'll duplicate that and put that in there. And that gives me perspective on my 3D coordinates. So going back to the draw stars, I'm going to call that new block perspective transform, and in there I'm going to do the X, Y, and Z positions of the stars. Just to make it easier, let's put them into variables first. So set world X, and we're interested in the indexed value of the list and the indexed value of the star X. So I'll duplicate that twice. There we go. So I can quickly set up world Y and world Z at the same time, getting the index of star Y, star Z in there. So world X, world Y, and world Z gives me the coordinates of the current star I'm looking at. And I want to do a perspective transform of that star. So I'll just put world X, world Y, and world Z into there. And that will return in screen X and screen Y where I can draw it on the screen. So I will simply go to XY, with that being now screen X and screen Y. And I'll just put my pen down and my pen back up again, and that will draw a dot of size 2 as set there. So pen down and then pen up. And then we're going to move on to our next star. So we're going to change the index by 1. And hopefully I've initialized stars. If I then draw the stars, it will show them, except I'm drawing white stars on a white screen. That's not going to work too well. Let's go to our backdrop and let's make space dark. So I'll change it to a bitmap so that I can quickly flood fill it. Color black. Boom. Space. Back to the code of sprite 1, which I don't want to call sprite 1. I'm going to call it space. Let's see what happens when we run this. We have lots of stars gathered closely together in a distance and spreading out all over the place. There's 1,000 stars there. That's great. Is the project finished? No. First thing I'm going to do, I think stars that further away should be harder to see. They should be darker. So let's add a brightness to our pen. And again, this was going to be in, if I make that smaller, in draw stars. So for each star, I'm going to set the pen brightness. So that's a pen function. It's actually set pen color, it's called. But I can drop the color box down and choose brightness. And I want it so that further away, the darker they are. So when they're close up, I want a brightness of 100. And when they're as far away as possible, so that they're actually at a distance of world size, I want them to be completely black, so they fade in as they get closer. So let's think about this. If we have an operator of the distance of this star, actually if I just move this slightly, so I'm setting the X, Y, and Z beforehand, because I can use those in this equation. So if I use the distance, world Z, and divide it by the world size, if it's very far away, world Z might be thousands, might be the same as world size, so that divided by that will be 1. And if it's really close, world Z will be 0, so it'll be 0. So this is going to give me a value between 0 and 1. I want to invert that. So let's do 1 minus. So now, when things are close up, they're going to have a value of 1, and when they're far away, they're going to have a value of 0. So if I multiply that by 100, close up will be 100, and far away will be 0. So I'll put that in my brightness, and let's see what that does to the effect. So now you can see the more times I click the green flag, the more stars I get. The reason for that is because I'm using pen, I need to erase all before drawing. If I click the erase all, you can see it wipes all pen from the screen. So now if I run the code, you see the stars in lots of different brightnesses. The really bright ones close and the dim ones far away. So that's a nice effect. What would be nicer if we can travel through the stars? So let's add another block called update stars. We'll run without screen refresh. I'll put this down here. I'll put it over here, just below drawing stars. So, although I'm giving the effect that we're moving forwards, I'm actually just going to make the stars move backwards. So it will be the same appearance. So I'm going to loop through all the stars again. So let's set index to 1. And let's loop through the stars using a repeat. Num stars again. Oop, in there. And we're going to steal a bit of code from there, because I'm going to use the same bit, the set world Z. So I've got the Z coordinate of this particular star, but I want it to move backwards. And how fast I want to use it, I'll add another variable called speed. And I'm going to set speed at the beginning to 0. Not moving at all. So here, I'm going to set the world to star Z. I want it to move it. We're moving forwards, the stars are moving backwards, so I want to move it to its position minus speed, so that it's moving backwards. Like that. Plus that. Change index by 1. So now I'm going through all the stars and they're going to be moving. Update stars. So I'm drawing stars and updating the stars. And I'm going to do that in a loop, because every frame I want to clear the screen, draw the stars, update the stars. Let's have a look at that. Nothing at all. But I think we know why that is. Should we show the speed variable? And let's double click on it a few times to get it as a slider. That slider will go between 0 and 100. So let's go on full. Let's increase the speed. Disappointingly, nothing at all. So we're drawing the stars, we're updating the stars, replacing, well, obviously what we're forgetting to do, we've set the world Z and we've changed it, but we haven't actually written it back into the list. So we will replace, I'll stop it running. We will replace item index of star Z with world Z, so it will be moving. And let's give that another go. Let's run the code now, increase speed, and that's interesting. They start coming towards us and then they move away, and that's because we haven't put a check to say what happens when the stars go behind us. When they go behind us, we don't care about them anymore, we can't see them. We have 1,000 stars, and when all 1,000 stars have gone behind us, we can't see any. So what we're going to do is say whenever a star has gone behind us, create a new one in the distance. So let's add a little bit of code for that, and we'll do if else, and I'll explain why it's an if else later. But I'll put that in there and make sure the change goes underneath it. If world Z is less than 1, then it has gone behind me. And if it's gone behind me, I want to restart it. So we will call place a new star. We don't need to actually delete it, we're just going to write new coordinates over it. So we're placing a new star at index with a depth, and we want it to be in the far distance, so the depth is world size. So when it's gone behind me, it will appear again in the distance. So let's have a look at that. Increase the speed, and now we have a nice star field that just goes on and on and on, which gives a really nice, impressive sense of depth, especially as they're getting brighter as they're coming towards you. But what I think will give an even better effect is if we, instead of just drawing dots of the stars, we actually show how far they've moved on each frame. So if they're moving fast, you're going to get a long line between them. If they're moving very slow, they'll just appear as a dot. So to do that, I'm going to have to make a couple more lists called previous screen X and previous screen Y. And I do this so that I can store where they were drawn on the last frame and then draw from that point to the new position each time. So I'm going to have to, when I initialize everything, I'm going to have to also delete all of those arrays lists. So I'll just copy 2 of these and I'll make it delete all of previous screen X and all of previous screen Y. Here, when I'm building the lists up to their full size, I need to add 0 to previous X and to previous Y. And in place new star with index, when I first place a star, it won't have a previous point. So how is it going to draw a line from the previous point? I'm going to have to set it up with a previous point. So what I'll do, it's already made a random coordinate. If I just call the perspective calculation on that coordinate, then the previous position will be set to where it starts. And that'll be a case of another 2 replaces down here of previous screen X and previous screen Y with screen X and screen Y from the perspective transform custom block. So that's set the previous values up there. Now I want to actually draw from the previous to the current ones, or I'm already drawing at the current ones. So how about at the current one, pen down, and then go to the previous one, which will be, let's copy this over here, will be item index of previous screen X and item index of previous screen Y. So I'm drawing from the current place to wherever it was drawn last time, and then I'm going to update the values of previous screen X and Y with the current values. The next time it goes through this function, these values will be the previous ones, and the new values will draw from there, and so on. So we need to replace item index of previous x with screen x, and the same for previous screen y, with right click on there and change it to screen y. Let's clean that up a little bit. And there we have it. So now let's see whether that works. Let's make it full screen, run the code, increase the speed a little bit, all dots, make it faster, and you can see as I get faster the lines are getting longer and longer. You can also see around the edges lines that are almost random, firing backwards. Now the reason for this, I go through this in every tutorial, is to do with how to move sprites smoothly off the screen. I'm going to put a link to the tutorial that explains this at the top of the screen in this tutorial, so just click on that if you're interested in that video. It's a short one that explains how to stop strange things happening when moving off the screen. So I won't explain it now, you can watch the other video if you wish. All I will do for now is add a set size to 1000 into the drawing function, and that will fix that particular issue. And now, to make it more fun, we're going to make it interactive. So we don't just watch it, we actually do something. I'm going to take the set speed out of there, and I'm going to move it to under erase all. I'm going to change it to, I'm going to add a divide into it. I'm going to use a mouse. So mouse Y, divide by, I think, 6. Now the screen coordinates go from minus 180 to at the top to, no, at the bottom to plus 180 at the top. Plus 180 divided by 6 is 30. To the top of the screen, that will give a speed of 30, and the bottom of the screen, minus 30. And so I don't need to show the speed indicator on the screen anymore. If I run it now, if I have the mouse in the middle, it's not moving. As it goes up, it moves faster and faster. And as it goes down, it moves backwards until we've run out of stars. We don't really want to run out of stars. That would be a pretty disappointing galaxy. So let's have a look. We've already got a check in here if the stars are going behind us. But what happens if we're moving backwards and they've gone beyond world size into the distance? We'll do a similar thing here. So we'll add another if then inside that, and it's going to be if world Z is bigger than world size, and it's gone too far away, we can no longer see it, and so we'll restart it right next to us. So now if I run that, if I go backwards, as soon as they go too far away and vanish, the random ones are being created right in front of me again, so this gives the effect of just going on and on and on through space. So I can, and I think the lines are a lovely touch. It really gives the impression of speed as you're going faster and faster. So let's stop that. And let's add one more thing to this. And this is the surprise thing. I'm going to add speed of roll for this sprite only. And I'm going to set speed of roll using mouse's X position divided by something. So that's a sensing block is X position, and I'll divide it by 40. So that will give a roll of 240 divided by 40, minus 6 and plus 6 on the left or the right of the screen. Well, what we're going to do with speed of roll, I'm going to add a new function. This is a mathematical function. I'll not go into the details of why this works. I'll just give you the basic formulas. So I'm going to call it a Z rotation because the z-axis goes into the distance. So if I rotate about the axis that goes into the distance, it's going to roll the ship. So z-axis rotation of the star at index, add an input index, and then add a label by angle and add an input angle. It really is a good idea to add labels just to make these custom blocks easier to read. Because if I didn't add the label, then it would just say index angle, which is quite clear, but it's nice to have it very specific. And in here, I'm going to set the x and the y for the coordinates for the world again, because it's easier to deal with coordinates than it is lists. So I generally move data from lists into coordinates, update them, and then put them back into lists. So this is going to be item index of star x, and this is going to be, just copy that, item index of star y. And now the mathematical bit. We're going to replace a coordinate with the rotated version. So it's going to be the same index, and it's going to be of world x, star x, and the same, I'll duplicate that, same thing for star y. And now this is where the mathematics come in. So in the top one, I'm going to add a minus operator, and in the bottom, a plus operator. In all of these, I'm going to add a multiplying there and a multiplying the other side, and this is going to be world x, and now a mathematical function. So I go to operators, and it says ABS, which stands for absolute value. I'm going to drop that down and change it so it's actually doing cos, which stands for cosine. So there's a bit of trigonometry coming in here. The cosine of the angle I'm rotating by, and I'm going to subtract the world y coordinate. There's actually some matrix mathematics here that you may have already covered, or you may, depending on how old you are, you'll cover it later on in maths. It's an interesting subject. I'm going to multiply it by the sine of the angle, and underneath that I'm going to copy this multiply block into the left side and copy the left-hand multiplier block into the right side, and just swap the variables. So this world y becomes world x, and this world x becomes world y, and that's it. That is the formula to rotate it around the z-axis. And I actually need to call that. So what I'm going to do in here, if this star has gone behind me, then I create a new one in the distance. If the star has gone too far away, I create one where I am. But if it's nice and visible, then we're going to rotate it, one at index. And how far are we going to rotate it? We're going to use the speed of roll that we just set up, depending on how far to the left or right the mouse is. Let's go full screen. Let's run this. And middle of the screen, nothing much happens. As I go forwards, it gets faster and faster. As I go back, I can travel backwards. It's a good spaceship, it can travel backwards. If I go left, then I rotate to the right, and right rolls to the left. So I can go fast and I can spin as I roll. As I zoom through space, I can be turning left, I can be turning right. And that is a star field effect. Now what you do with this, it's got many applications. Obviously you could have a 3D space game, or you could just have this effect going in the background of any game that you've got. In a way it looks like rain pouring from overhead, or it could just be an interesting backdrop going on. You could have each star being different colours. You could make them get bigger as they get towards you. You could play around with this. There's a lot you could do with this. It's quite quick to set up. It's a lot of fun and it looks visually impressive. I'm going to actually link a project from this YouTube tutorial. The link to the project will be this, but with some extensions built on, just possibilities of what you might think of doing to give you some other ideas. So I hope you've enjoyed making this star field. If you have, then please don't forget to subscribe to the RokCoder YouTube channel, and I'll see you again next time.